fill the room reasonably well. And if I go like that, can you still hear me at the back? Or?
Yeah.
Yeah, great. Okay, hi, good morning. I'm Hamish, I'm from Sheffield. If you're from Manchester and you don't know where Sheffield is, it's in the big, important county to the east. And you lot live just outside it. But don't worry, we don't look down here too much. Some of my best friends are from Manchester. Really? So, I'm from the Computer Science Department in Sheffield. We're running an outreach program for local schools. A few weeks ago we had 50 kids in, we gave them all a Raspberry Pi. Alan Mycroft from the Raspberry Pi Foundation came and kicked it off and stuff. We gave a very exciting talk, and then it was time to go to the laboratories. And I walked across the road with these 50 kids behind me, feeling something like the Pied Piper. Walked into the lab, walked up to the rig with all my Pi gear that I'd carefully set up the night before, and there was no power. Somebody had nicked all the cables. In fact, the look of horror came across my face. What the hell am I going to do now? It was even more annoying because it turned out it was one of our own technicians who'd nicked all the cables because I plugged one into the other, which is naughty from an electrical point of view, apparently. So I'm really pleased to be here today in a fully mobile battery-powered configuration. And for the last year or so, we've been doing various projects that involve mobile Raspberry Pi of one sort or another, and I'll introduce a couple of them in this talk. And we came to feel that we needed a new gizmo to make this a bit easier, so we've developed this little add-on board called MoPi at the moment. If I plug this in, you'll see the light come on. It's a tiny little circuit, looks like this. Costs a few quid to manufacture. It's actually made in Bulgaria, strangely enough. And it's an add-on board that goes onto the GPIO pins, and it'll power your Pi directly through the GPIO. It's got a number of nice features for mobile applications. So you can plug in any old kind of battery set. So here's a set of standard off-the-shelf commodity batteries. You can plug in an old laptop charger. It'll cope with voltages up to around 25 volts. You can plug in your car cigarette lighter if you want to. And when your battery pack runs out, it's got two inputs, so you can kind of do a hot swap thing. You can get a new battery pack, plug it in without the Pi shutting down, and carry on working. My brother spends his weekends tramping around a thing called Kinder Scout in the Peak District, which is one of the big peat bogs on top of the peaks. And it's suffering from a lot of erosion because of things like acid rain and pollution. There are some bits of vegetation there that don't hold the thing together anymore, so they're looking at reseeding it and so on. And we're going to put one of these in a box with a waterproof setup with a Pi camera and so on. And it's important for it to run for a long time. So we'll have a Model A Pi, we'll have some lead acid batteries. You can start to look at having the thing running for weeks at a time without having to maintain batteries all the time. So I've got 3 demos with me today. That's the main one. You'll find source code and documentation for all this stuff online. You can just about read it. pi.gate.ac.uk. There's a little daemon that goes with the battery pack that you install. It's all packaged up for Raspbian, and we've sent it off to Raspbian maintainers and so on. And the daemon sits there and listens to signals being sent from the add-on circuit. When the battery starts to get low, it'll start flashing a red light here. It'll give you a warning on the computer. It'll tell if you're working on the computer, you'll get a pop-up message saying you need to change your battery pack. You can either change your battery pack, or eventually the circuit's going to tell the Pi to shut down cleanly. So you avoid that problem where the Pi gets a hard reset and potentially corrupts your SD card. Because we were dealing with turning the power off or on and off already, we thought we'd have a power switch. So there's a little power switch there. I was talking to Paul from Pi Moroni, and he's up for doing a special top of the case. This is a Pibo case, also made in Sheffield by Pi Moroni. We'll have a special top with a little hole, and we'll make the switch a little bit more accessible there. Okay, so I'll have a bunch of demos of that stuff down in the corner down here, running various projects, which I'll just run through now. But first, because we wanted to add some software to the distributions that run on the Pi, so we wanted to add stuff to Raspbian, mainly. I spent some fun times this summer learning about the Debian packaging system, which is what the Pi uses to package up software and deliver it and so on. We also use, for a lot of our projects, we use a thing called Wiring Pi from a guy called Gordon Henderson, which is a library that talks to the GPIO pins, that allows you to read values from it and so on, set values very, very nicely. So when we've done the wrapper for the MoPi little mobile device, we also did a wrapper for a package for Wiring Pi. So you can now go and install this with a two-line command instead of you used to have to download this, build it locally, do make install and so on, which is great for people like me, old fossils who like the command line, but it's not very user-friendly. So we've just pushed that out to the Raspbian maintainers, and hopefully they're going to include that in the main distribution soon. It's quite a tricky process. Anybody done Raspbian Debian packaging? It's not the easiest thing in the world to learn, is it? So we're also, as we're doing these various projects at the university, we're trying to push them out into the community and find stuff that, especially stuff that excites people in the younger generation to get involved and so on. So all this stuff I'm talking about you'll find on our website. There's a tutorial there about packaging for Raspbian. And some things turn out to be, you get some easy wins that you don't expect. It turns out, for example, that if you're only using a script language, the thing that manages the battery pack is in the bash script, shell script, or if you're doing Python or something like that, you can actually get the stuff to work on an Ubuntu archive. Ubuntu doesn't work on the Pi, but they have this nice infrastructure, including the personal package archives, where you can contribute your own archive and they'll build it and so on. And if you're only doing scripting, then you can use a PPA. So we deliver our software now with a PPA, and you'll find instructions on the website that allows you to add the GPG key from Ubuntu. It's quite a nice, easy way of installing software on the Pi. Doesn't work, unfortunately, for Wiring Pi because that's a C program and binary and so on. So that was number 2 in the journey. As part of this process of trying to find projects that school kids are interested in, I think the conclusion that we've really come to is that you need to do something with GPIO pins. You need to extend the thing in some way. You need to collect some electronics, some robotics, some sensors, stuff like this. That's what makes the Pi interesting and different. If you just, I gave a Pi to my nephew early in this game. He was, great. Oh, it looks nice, But then you plug it in and start using it. It's basically a slow computer. If you're well enough off as a child to have lots of access to computers already, the Raspberry Pi isn't necessarily immediately very exciting. But as soon as you start plugging things into the extension header, then the game changes. And in this project here, what we did was we took a little thing called an X-Low board, which has an accelerometer and a compass on it. We strapped it onto the top of the Pi with a bit of tape, and we put a battery pack underneath. And if you've got 2 Pis, you set one up as a server, and it's a kind of virtual paintbrush affair. There's a couple of hundred lines of Python code that runs on the server, and you wave the accelerometer around, and you can splash virtual paint drops onto the screen like this. Who's heard of Jackson Pollock? Who remembers Jackson Pollock? Yeah. There was a very famous artist in the 60s who did this. It was physical paint, now you can do it on the screen with the Raspberry Pi. It's a kind of poor person's Wii. Or perhaps a rich person's Wii, because the Wii is totally closed, but this is all open source software. There's going to be an article on this project in the Magpie in December, and the Expo people are giving away prizes. So if you think of something really interesting to do with an accelerometer and you send it to them, then you can win one of these gizmos. So that was pretty much all I really wanted to talk about. I've also got downstairs one of those cameras that I mentioned, so there's a little camera in a lunchbox with a 15-inch screen, car reversing screen in it, serves directly onto the web, so come and have a look at that. And we're sort of moving towards a Kickstarter for this thing. So these cost around 15-20 quid, or they will cost around 15-20 quid, well, if we can get enough of a production run. So we think we'll use Kickstarter to try and publicise the thing, try and get a feel about whether anybody in the community actually wants one, and get pre-orders and fund the initial production of the thing. So if you're interested in it, please come and have a look downstairs. And that's pretty much my time. We've got a couple of minutes for questions if anybody's got them.
What sort of typical run time do you have from depending on the battery? Do you get 4 AA's or something like that?
So these are very high capacity batteries which work best. These are nickel metal hydride. So you can't really get away with 4 because they're only 1.2 volts. But if you've got a pack like this, which is 8 batteries, and your Pi's not doing very much work, it'll last about 9 hours. Better for the Model A. Model A you maybe get about 15 hours. You can also plug 2 packs in at the same time, and you basically get double the load. So you can pretty much, you can with a couple of these, you can do a day using 24 hours.
What application are they normally used for, those battery packs? Is that a laptop battery pack?
No, this is just pop down a map lid. You get one of these little plastic gizmos that contains batteries, and get them all different sizes, and these are just standard batteries from RS, Duracell do them as well.
How long are you hoping to get with the lead acid battery you were talking about?
I don't really have any idea because I haven't looked into how much charge they store. I mean, it obviously depends on the size as well because they come right down to these tiny little things. But for the application on the on Kinder Scout, we really need to get a week out of it. But if the battery runs out before the person comes back to collect the pictures, that's not a big deal because it's going to shut down cleanly.
Would it be possible, given that you can chain them together, to have a lead acid battery and say a solar cell next to it, so that you could relieve some?
Yeah, definitely on the list to try. I think solar cells tend to put out a pretty low voltage.
Will that work on the top of Kinder?
Well,
Good question.
Yeah, possibly a little
hydroelectric
turbines we do that.
Wind turbine.
Yeah.
In terms of the monitoring on Kinder, how much does the Pi actually need to do? How long does it need to run for?
They tend to go up once a week.
No, but in terms of the data you're collection, what is the rate that you're collecting data? Is it once a second, or is it once every 10 minutes? And
I think, really what they're interested in is the way that the water flows happen when there's a lot of rain going. And I don't know. I think I'm going to have to get it up there and try. It might even make sense to take video at the particular time when there's a lot of water flow that they're interested in, or when the light conditions are good. If anything, I've found with the Pi camera, it's very good, but the lighting conditions have to be right. Well, actually, I haven't tried configuring it for different light conditions. I know that you can, but if you've got that wrong anyway, then you don't get very good results. So it might be good just to switch it on and take a video whenever the conditions are right. Yep.
Are the regulators used on that board, are they more efficient than the ones that are on the actual Pi, or are they the same ones?
The Pi doesn't have a switch mode regulator, I don't believe.
So you're using switch, right?
It's a switch mode regulator.
So it will be more efficient than, so you'll probably get more battery life than feeding it through the regulator directly.
If you want to connect the battery directly, you need to buy one of those packs that supply a good stable 5 volt, and they have a regulator in already.
Okay.
The ones, the biggish chunky ones about that size, they'll get almost exactly the same life as one of these.
Okay.
The disadvantage, there are 2 disadvantages. One is when they wear out, you've got to chuck them away. You've got no, these are reusable. You can recharge them and just replace the batteries. And the other main disadvantage is that
Time's up.
Outside.
Well, I don't have to answer that question then.
I've started.
The thing is that when the battery runs out, the Pi just gets a power cut basically.
Yeah.
And you know, about 1 in 20, 1 in 100, maybe 1 in 100 times that's going to corrupt your SD card. And
That's 1 in 2 times.
Yeah.
Easily. Yeah, exactly.
So this will actually shut the Pi down cleanly before the power. So thanks for your attention.